This video is for integration and U substitution. And the idea for U substitution is if you look at the equation that's given, and if you were to take the derivative, not the antiderivative, if you take the derivative and you have to use the chain, product, or quotient rule, that suggests that U substitution is probably the technique that'll work for you. So this example 1, we have an exponent on the outside of the parentheses, which suggests the chain rule. So that's going to tell us try U substitution. So pick the U is going to be the inside. And you want to take the derivative of that. And what we ultimately want to do is our left column to have everything with the U's and no X's, and the right column to have everything with X's. So we have the U and the DU, and that's what we're going to use to substitute in. But you might notice that there isn't a -2 in our original function. There's a 6. So the easiest thing to deal with is move the -2 over with the U so that we just have the X. Now there's other options you can do, but that's the easiest, as I said. So now we're going to not erase the highlight. Oh, I'm going to erase everything and rewrite that. Okay, DU, and highlight the correct part now. So those are the pieces that I'm going to use to make the substitution. So I go back to my original equation and say equals, and the 6 is a coefficient. I'm going to put that out front. The divide by -2 is a coefficient, so I'm going to put that out front. My integration symbol, and in the parentheses I have the U to the 4th power, and in place of the dx, I'll have the du. So everything that I have on the right side that's highlighted is present in the original equation, and then I substituted it with the left-hand side. And of course, we can do a little simplification there. And the antiderivative of U to the 4th, add 1 to the exponent, divide by that new thing, plus K. And then always put back in the U, like that. And that's our answer. And you can, if you're unsure, double check this by taking the derivative of the answer that you just had. And this is good practice because you're going to have some derivatives on the final exam. So you may as well refresh your memory a little bit. Okay, so the -3/5 is a coefficient, so it's going to be there. And then we have parentheses. I'm going to fix that parentheses so it looks a little better. There we go. I'm going to fix that parentheses so it looks a little better. No, just fast forward. There we go. So now the exponent goes in front. The inside stays the same. Subtract 1 from the exponent. Derivative of the inside, and the derivative of a constant is always 0. And you can clean that up a little bit. You can see that the 5s will cancel, the negatives will cancel, and we get 2 times 3. And that's the function we started with. So it's kind of a close the loop sort of idea, the antiderivative, and then you can go backwards to the derivative, and you should, be able to see that you did it correctly. So let's try this next one. So this one's a little bit different, but there is still a parentheses with an exponent, this time in the denominator. So that's a good choice for the u. And you don't want the exponent because you want to end up with the u to a power. You're going to turn these into the power rule so that they're very easy to deal with. And I wrote this, I skipped the middle step with the du dq. I just moved the dq to the right. We have a similar situation to that first example. We have a 3 that is not present in the equation that we're given. So I'm going to move it to the right with our u. And I'm going to highlight. We always use the u that we picked and the final du with the manipulation of the coefficient that we might have there. That's what we're going to use to substitute. So the original equation has a 5 coefficient, move it out front, a divide by 3, move it out front. And now our denominator becomes u to the 4. And our numerator, we had a q squared, that's taken care of, and the dq, that's taken care of. So that's going to be my du. And I'm going to rewrite that using my exponent laws. So that u in the denominator gets that -4 when we move it up top. And now I can use the power rule, add 1. I keep forgetting it doesn't erase like that. There we go. There's not an actual eraser on this pen. So add 1 to that and divide by that new thing plus k. A little bit of cleanup here, so we'll have -5/9, and then put the equation back in that you picked with the right variable. Like that. And I'm not going to double check this one, but feel free. I probably screwed it up. No, I didn't. But anytime you're not sure or you're still just learning, go ahead and take the derivative of that answer and make sure you're doing the antiderivative correctly. Alrighty, let's look at the next page and try this again. So this one has an exponential. And so the good idea is picking the exponent of the exponential. Now we need to deal with the coefficients. So my original equation, there's a 7 and a negative in front of the integral symbol. Well, my du has a negative. I'm not going to worry about it, but it has a 3. So I am going to move that over to the left with the du. And highlight again. And then go back. So I've got the divide by 3, and we're going to replace the negative. So I'm going to not have a negative anymore. And actually I need the 7. So I'm going to make that 1 into a 7. There we go. So my coefficient 7 and divide by 3, I've got that taken care of. So now my e to the u, and then the negative x squared dx are all going to get replaced or substituted with that du. Like that. So 7. And the idea here is that the antiderivative or derivative of e to the u is e to the u. So we're making it easier to deal with. And then now substitute back in. And again, if you want to double check this by taking the derivative, we will do that. I'll do this one since it's a little bit different, involving the exponential function. Alrighty, so 7/3 coefficient goes out front. The derivative of the exponential starts off with nothing changes, the exponential. And then we have the derivative of the exponent, and only the exponent. Derivative of the constant is 0. So the 3's cancel. The negative and the 7 and x squared and e to the negative x cubed. And that's what we started with. Double check. All right. And our last one is kind of a combination. If you look at example 2, we have a denominator, but the denominator has a power. So we pick the denominator, but not the power. And in example 3, we have an exponential function, and we pick the exponent of the exponential function. So now we've got a combination. We've got a denominator and an exponential function. So the denominator kind of takes precedence. So we're going to pick the entire denominator. And there's not a always do this kind of situation. These are just suggestions. You've got to get a little comfort with it. And take the derivative. Remember the derivative of that minus 3, derivative of a constant is 0. And this is another chain rule with the exponential. And I don't have a 10, so I'm going to move it to the left with the u, change the multiply to divide. Like that. Highlight. So we're going to take our u that we picked and the final du that we manipulated with the coefficient. Make our substitution. So divide by 10. I move it out front to not worry about it. My denominator was the u, and my numerator and the dx turns out to be the du. And anytime you pick the denominator, the idea is you want it to be u to a power. And then you can move on from there. Okay, now this is an example of one of our special rules for the natural log. Remember, the power rule says add 1 to the exponent and we get u to the 0. And that's not going to be very helpful. So we have to remember in this case, we're going to have the natural log absolute values of u and then the plus k, and then plug that back in, the actual part that we substituted. 10x plus 2 minus 3. And again, take the derivative. Remember the derivative of the natural log, what's inside goes in the denominator. And then its derivative goes in the numerator. Like that. So that is the end of the video. Thank you for watching.